Hello guys, welcome back to the channel. Today we will be solving this Leetcode medium question 3342. Yesterday we solved the part 1 of this question, find minimum time to reach last room, and we'll see what the problem statement says and what is the difference between yesterday's problem and today's, right? So there is a dungeon with n cross m rooms arranged as a grid. You are given a 2D array move time of size n cross m where move time ij represents the minimum time in seconds. Okay, you can start moving to that room. Fine, you start from the room 00 at time t equal to 0 and can move to an adjacent room, right? Okay, so moving between adjacent room takes 1 seconds for one move and 2 seconds for the next, and alternating between the two, right? So return the minimum time to reach the last room, that is n minus 1 and m minus 1. Okay, so two rooms are adjacent if they share a common wall either horizontally or vertically. This says so. So the difference between yesterday's problem and today's is adjacent rooms take 1 second for one move and 2 seconds for the next, right? Okay, so let's see how it is different from yesterday's. So suppose there are four rooms, or we can add uh, two more, right? So uh, so to move from this first room, let's number them as well. One, two, three, four, five, six. Right. So yesterday when we moved from room one to room two, we were taking 1 second. Similarly, for movement of between any rooms, we were taking only 1 second, 1 second, 1 second, 1 second. But today it is not the case. What's the difference? So when we move from first room to second room, we'll take 1 second, right? But when we move from this is 1 second, and when we move from 2 to 3 or 2 to 5 anywhere, this will take 2 seconds. Okay, so this will take 2 seconds. And then when we move from 5 to either 6 or 3 to 6, right? This will again take 1 second. So there is an alternate odd even or one or two parity which changes from moving from one room to another, right? So if you want to understand the whole scenario, how to approach this kind of problem, you can go and watch my yesterday's video where I explained the whole thought process and why we'll be using Dijkstra's, not BFS. I'll mark down the link in the description as well as over the I button. Also, we'll see how we can use yesterday's code and use that code to solve today's problem. There will be a very slight change, right? So we'll take that part and paste in the problem and we'll see what needs to change. Okay, I'll just copy paste here. Just for a reminder, yesterday what we did is we took a matrix to store our distance, right? Initially everyone to infinity. Okay. Also we took a priority queue where we stored the row, column and the time because we have to find the minimum time, right? And then as per the door opening means the move time, we move from one node to other, right? So today I just pasted the yesterday's solution in the problem, and let's see what slight changes we'll do, and this will solve the problem efficiently, right? So we need a we need a value which will act as a parity for us to mark down odd and even nodes. So this will be 1. Initially, we'll move from one node and it will take a distance, a value of 1 to move to the second node, and then in the next step it will take 2 value, right? So I used 1 here, right? All the code will be the same, only we need a parity. So int, so this will be in the node third index, and then as per the parity we'll add the new time. So yesterday we were adding 1 for all the steps, but today we'll be seeing what's the parity, and then we'll add it, right? So here we'll add the last parity, and then when we are adding a new row and column in the priority queue, we'll see first if parity equal to 1, then for the next iteration we'll be taking 2, right? Else we'll take 1, right? Okay, so I believe it is good to go, and then we'll see uh, what we get. Okay, where line 55. Okay, we have a extra boom. Yeah, so we just have to understand the pattern. And yesterday, what we did it is just understood the use case, and today we just slightly improved the problem, and then it is done, right? So thank you for watching. Do like, share, and subscribe. We'll see you tomorrow. Bye bye.